Hello, good morning students. This video is a revision about what we learned in the last online lesson. First of all, last time we introduced the concept of gradient for a slope, or we call it inclined plane. Okay, we call this one as horizontal distance. And of course, this one we call it vertical distance. Okay, and then to calculate gradient, which is used to describe the steepness of the inclined plane, this one we call it the inclined plane. Okay, to describe the steepness of this, we can have a concept called gradient, which we use vertical distance divided by horizontal distance. So you can see that if the vertical distance is increased, if this one is increased, means this one, the vertical distance of the same slope, is increased longer. And then if we keep the horizontal distance, then the resultant slope, this one, will be steeper. Similarly, if we decrease the vertical distance, and then keep the same horizontal distance, you can see that the resultant slope, this one, will be less steep. Okay, so for steeper slope, means a greater gradient. Less steep means smaller gradients. Okay, so we can have one example here. This one. This time you have the inclined road, and then Tommy slices it down, and you have two distance, 33 here. Note that this one 33 is the length of this line PQ, which is the total length of the inclined road, and then 30 here is the horizontal distance, so we don't have the vertical distance this time. So part A asks you to find out the vertical distance. This one is a right-angled triangle, so you can apply Pythagoras theorem here. So we have 30 square plus PR square equals to 34 square. We use Pythagoras theorem, and then we know that PR should be 16 meter. So the vertical distance is 16 meter. Part A. And then for part B, it tells you to calculate the gradient. Okay, gradient, this one, can be calculated by vertical distance divided by horizontal distance. So now we have the vertical distance also. And then the requirement is we have to express the gradient in form of 1 over n, where n is corrected to the nearest integer. Notice that only n is corrected to the nearest integer, but not the whole 1 over n. Okay, so we need to find out the value of n first. Gradient can be calculated by vertical distance, which is 60 meter, divided by horizontal distance, which is 30 meter. Further equals to 1 over n, because we need to express the gradient in form of 1 over n. We want to find out the value of n correct to the nearest integer. So just consider this part to find out the value of n. So n is around 1 point something. So after rounding off, it should be 2. So approximately equal here. Therefore, the gradient is 1 over 2. Remember, please restate the gradients for me, because I'm not asking for the value of n. Instead, I'm asking for the value of gradient. So after calculating the value of n, which is 2, you need to restate that. Tell me once again what is the final gradient. Okay, so this is the end of this revision clip.